Good afternoon. Today we are going to see a topic about addressing modes in digital logic microprocessor. So addressing modes, it means it defines how CPU identifies the location of the operand required by an instruction. So here what does instruction mean? It is a basic command given to a microprocessor to perform a specified operation within the given data. So operands may be operands or maybe it include register, memory, instruction and input output ports. So what is meant by opcode means it defines what operation will be performed by the instruction. Next, operand, it specifies the data on which operation is performed. The way in which operand or data is specified in an instruction is called an addressing mode. So coming to the addressing modes, why the addressing modes are needed means it handling data efficiently. So accessing memory in different ways. It simplifies assembly language instructions and reducing program size and increases the execution speed in 8086 microprocessor. So classification, we have immediate, register, memory, base indexing, indexed, base index with displacement mode. So coming to the first, register addressing mode. Here the data which is in the register is specified in the instruction, so which is called register addressing mode. Here see the example, move AL, BL. Next, immediate addressing mode. So the 8-bit or 16-bit data is specified in the instruction directly. So here move AL, 25H. This data is specified in the instruction to the AL directly. Data memory addressing, direct addressing. The 16-bit offset address or effective address of the data within the segment is directly given in the instruction. Here we can see the example, move AL, 1000H. So the 1000 is the address here. Next is base addressing. The 16-bit offset address or effective address of the data is given in the base register or base pointer. So here example we see BX is a base register. Move AL, BX. Next is base relative addressing. So coming to the base relative addressing, we compare that the 16-bit offset address, more effective address of the data, it will be obtained by adding the content of base register along with the 18 or 16-bit displacement mode. Here move AL, BX plus 5. Here BX already, the base index we are added, the plus 5 is a base relative addressing. Next, index addressing. The 16-bit offset address or effective address of the data is given in the source index register or destination index register. Here example we see move BL, SI. Next is index relative addressing. The 16-bit offset address or effective address of the data, so it will be obtained by adding the content of the index register along with the 8 16-bit displacement. Here we see first the relative addressing, we put move AL, SI. So in index relative, compare it, we are putting move AL, SI plus 5. The SI indicates source index. Next is a base plus index addressing. The 16-bit offset address or effective address of the data, it is obtained by adding the content of base register, the BX or BP, whatever we can use, and the index register, source index or destination index. So move AL, BX plus SI, that is source index. Next, base relative plus index addressing. The 16-bit offset address or effective address of the data is obtained by adding the content of the base register, BX or VP or index register, source index or destination index with an 8-bit or 16-bit displacement. So which is indicated by her example, move AL, BX plus SI plus 15. program memory addressing mode or direct addressing. So here we directly write as JMP, the value and H. This is a example for program memory addressing mode. Next is indexed addressing. So in compared to indirect addressing, here we see the example JMP CX, that is jump.